Hello everyone, I'm Subjit Roy welcoming you to mojo4industry development debate on why partial discharge testing is important. The knowledge partner for the session is Fluke Corporation and co-sponsor is Next Gen Equipments Private Limited. Partial discharge is a localized breakdown of electrical insulation that occurs within the equipment such as transformers, cables, switchgear, and other power apparatus due to the presence of small voids, impurities, or defects in the insulation material. If not detected and resolved, partial discharge can lead to more serious faults, equipment failure, and downtime. Partial discharge testing is important because it is a diagnostic tool used to identify potential faults in high voltage equipment. Today, in this mojo4industry development debate, experts will help you to understand the importance of partial discharge testing in detail. The knowledge partner for the session is Fluke Corporation and co-sponsor is Next Gen Equipments Private Limited. Ladies and gentlemen, before we get started, let me introduce you with our panelists. We are pleased to join by Mr. Prabhakaran PV. He is the head project management at Fluke India. Welcome, Mr. Prabhakaran. And then we have Mr. Dr. Rajesh Kumar Arora, who is the senior manager technical design and engineering at Delhi Transco Limited. Once the individual presentations are over, we will have a panel discussion followed by a Q&A session. So delegates, if you have any question for our panelists, please submit it in the Q&A box in your Zoom control panel. We will address them at the end of the session. So now to take the session forward, I will invite Mr. Prabhakaran. Mr. Prabhakaran heads the product management team at Fluke India. He is a trained thermographer and having more than 16 years of hands-on experience in the field of power quality and energy management. During his tenure with various reputed organizations, including Fluke, he provided solutions to the energy producers and consumers in these fields. He is also instrumental in training Fluke customers and channel partners on this subject to ensure the usage of the tools for reducing energy wastage and improving power quality. He is going to talk about the importance of partial discharge testing. He will also present some of the advanced partial discharge testing and monitoring solutions. Over to Mr. Prabhakaran.
Thank you for that nice introduction. Let me just share my screen so that we can be clear what I am talking. I hope the screen is visible.
Is visible, sir.
Hi, good afternoon all. It is my pleasure to face you virtually, and we are continuing the learnings what we had from the corona. Thanks to the corona that we are connecting virtually. Even the good learnings we are continuing still. I think the mask and the crowded places, and this also is another good learning. We are getting this, and thanks for mojo4industry for inviting us for this kind of talk. This very important talk because the safety is paramount for everyone, and partial discharge can take your safety for a toss. That's why this topic is very critical and less understood in many of the industries and even in utility segments across India. That's why I am Prabhakaran. I head the product management team or product marketing team in India, and I am with Fluke for last 18 years. And just before going into the today's topic, I am just giving you a brief about Fluke. Fluke is celebrating its 75th birthday or 75th anniversary this year. Way back in 1948, John Fluke Sr., the visionary technocrat, started this company in his basement, designing a very accurate power meter for his former employer, that is GE, General Electric. And from that, we have grown leaps and bounds, and today we are represented in more than 100 countries with nearly 4,000 product lines in our kitty for maintenance, predictive maintenance, condition monitoring, even solar and EV segment testing. We have the complete test equipments, and we also have when in our journey, we have a lot of milestones. I am just giving you a few. Like in 1977, we introduced the world's first handheld multimeters. Before that, multimeters were there, but this is the time we introduced the handheld one, and we became synonymous to the handheld multimeters. And again, we are one of the largest measuring or the calibrator manufacturers for electrical, mechanical, or the pressure and temperature kind of parameters. We make the highest accurate standards. And similarly, in 2005, we actually launched our thermal imagers. Those days, thermal imagers were very costly. And when we introduced our product, we could brought down the price. And then today, we are one of the largest selling thermal imaging companies. And in 2019, we introduced a very interesting product that is acoustic imagers for leak and partial discharge detection. And just a few months before, we also launched a all-in-one solar analyzer, which is helping the solar industry or solar engineers to work very easily in the solar field and to find out how effectively their solar power stations are working. And we still continue the motto of our founder, John Fluke Sr., that he believed in giving the safest product at an affordable price. And he also believed that every customer has the right to get a little more than what they thought they paid for. That legacy we still continue. And today we also have the complete range of products for electrical utility maintenance and the industry as a whole. And today we have the largest fleet of equipments for the connected maintenance. That's Industry 4.0 applications too. Going forward, today's topic, partial discharge. What is partial discharge, or why partial discharge is important? To general public, I have put it very, very crisply here for every layman to understand. And my fellow panelist, Dr. Arora, will be talking in detail, I hope, in the technical aspects very nicely, because I don't want to steal or step into the experts' shoes there. And what I am trying to talk here is how this partial discharge can, what is partial discharge and how it can affect your life. That is what I want to just touch upon. In fact, partial discharge is the electrical discharge that is not completely bridging the gap or in between two conductors. If there is a kind of discharge happening, that is what is you call it as partial discharge. It can occur in low voltages also, but usually the partial discharge occurs above 3 kV. Okay, any system which is working above 3 kV is expected to have partial discharge. And in other words, the PD is the inability of a portion of the insulation to withstand the electrical field applied to it. This is actually a very interesting subject, because in electrical engineering or electrical systems, the resistance and electricity and the insulation material actually plays a major role. Every equipment is designed with conductors and insulation, right? Insulation material. And this has to work in tandem appropriately, then the machines will work. The moment if there is a kind of failures or weakness in the insulation, the partial discharge pops up. Where does it can happen? Any insulation, any high voltage lines, any transformers of high voltage transformers or turbines or bus bars or cubicles of bus bars and switch gears, or even the high voltage cables or its joints, all the places wherever the high voltage is present, you can expect partial discharge also. What it can do to the materials or the equipments, it can have mechanical changes or mechanical effects, or it can have thermal effects, or it can have chemical damages to the components, and it can also have various other unwanted effects. Okay, we will see those things in the later slides. When it comes to partial discharge, you have broadly, there are 4 different kind of partial discharge categories. That is, one is the corona discharge, the other one is arcing, and the third one is surface discharge, and the fourth one is the void and or the internal discharges. The corona discharge is usually PD is known as corona discharge in many places, and many customers prefer it as corona discharge. But corona is one portion of the partial discharge, and many of you would have seen working in the high voltage switch gears and then transmission lines. You would have seen such lightning pattern at night or in the evenings. This is actually partial discharge or the corona effect. This is basically when the high voltage is available at the sharp edges of terminals. This can the high voltage try to pass through the air or the gas available in the atmosphere, and this try to do the ionization process. And because of this, this can create the light. This can also create sometimes the ozone, and it can also create interact with nitrogen, and it can create nitric oxide. And nitric oxide can even create acid rain if it is small. Okay, that's why there are chemical effects, and you would have seen some of those components are having the white powdery coating, oxidization coating on the components. That is basically because of the oxidization happening. And similarly, the arcing is basically the electrical breakdown between two conductors and creating a plasma kind of discharge. You can see here the plasma kind of discharge happening. This can be because of the insufficient spacing or some failures in the insulation or a kind of loose contact. Any of those kind of things can create this kind of arcing. And then comes the surface discharge. This is another interesting thing, and you would have seen most of the time the components or the bus bars or the metal parts or even the insulation material is getting some tree formations. This is basically what happens when there is dust or the moisture or even the weaker insulation material is there. Then the electrons start trying to reach the nearest zero potential location. That is what it does, and it damages over a period of time the entire insulation. And voids, this is basically happens because of the insufficient or the manufacturing defects, or if there is something internal damage is happening into the insulation material. It is usually you will not be able to find it with your naked eyes. It may happen inside, and there can be a void, and these electrons start jumping from one end to the other end. Usually this insulation and resistance makes a capacitive effect, and this capacitance comes down or increases. There can be a kind of high current pulses jumping through these voids. And this also you may not be finding it, but when this is too much and it breaks down, you will find the entire insulation is broken down, and it can lead into some kind of fire accidents. What happens, how it is touching your life? The insulation degradation over a period of time. That is, if the partial discharge occurs the moment you start your system, it's present because high voltage is present, insulation is there, and there can be external challenges like stresses, like moisture, dust, all kind of conditions which can actually accelerate the partial discharge conditions. Then failure of equipments. This can contribute to failure of equipments, which will put your precious time into the maintenance, and then you may have to do over maintenance, or you may have to do the replacement. Then safety and fire hazard. If the insulation fails, if you are not attempting to identify what is the partial discharge and how it is growing, and one fine day your system may come off and it can lead into fire accidents or a blast. And this can lead into very catastrophic failures and also death. And loss of money, definitely when you want to have this kind of assets, and if you are not maintaining that, or if you are not concerned about this partial discharge and you're not checking it or verifying it, there is a possibility that you may have to replace, or your life of your costly assets may come down, and you may have to replace it periodically. And then more importantly, the power outage, because you are the people who are talking about the high voltage equipments, which is usually used in the utility segments. And when the utility goes down, the entire country or the entire village or entire city goes down, and everything stands still, and it takes more time and then money for you to bring it back. And as I put it here, the uptime, that is, if you are detecting the partial discharge, then you can keep the uptime or every machines and every industry running throughout, and the production and equipment quality can be improved. Then cost and energy saving, that when your equipments are maintained well and it is in service, you are actually saving money. And safety, This is the important part. Most of the, there is a study in US or Europe, I'm not very sure, that 85% of the medium voltage and high voltage electrical utility failures, that is catastrophic failures, are happening because of partial discharge. And this is true. And many a time in India, unfortunately, we don't categorize it under the partial discharge failures, or we don't do that kind of analysis post accidents. And when it comes to the partial discharge detection, as I said, when partial discharge occurs, when the partial discharge breakdown occurs in installations, it can discharge, or it will give the outputs like light, heat, smell or gases, and sound, apart from the electromagnetic waves. Okay, that means you can detect the partial discharge using various techniques, either through light or through heat or through acoustic emissions or through electromagnetic emissions. And if you see this portion of the screen, there are various, even chemical analysis can help you to find out what is kind of gas presence in that partial discharge conditions. And you also can use acoustic emissions and then electromagnetic emissions. All this while even IEC, IEEE and all was making the standards mainly basically on electromagnetic detection or the electrical detection based on the sensors, electrical sensors. And this is the time we have actually launched an acoustic emission method. It was there previously also, but what we have done is we have come out with an acoustic detector or acoustic imager, which can really detect the partial discharge and tell you what kind of partial discharge it is and where exactly it is. That is what actually we have done in 2020. Through partial, even though the partial discharge creates the various frequencies, the frequency varies for different things. Light will have different frequencies. The heat coming out of this partial discharge will be different frequencies, and electromagnetic waves will be of different. That is, the electrical current may be of very high frequencies also. That's it. Every technique has unique sensor requirements and unique advantages and disadvantages. When it comes to the PD, you have to have the PD detection and localization location, locating of PD in your utilities. And also you need to have the analysis and diagnosis part even in the manufacturing segment of transformers and the motors and all. You need to have even the quality testing with partial discharge. Otherwise, you will be leading to a lot of sending out faulty equipments. When it comes to this screen is showing you how an acoustic imager can help you to find the partial discharge detection. And this is actually the Fluke's partial discharge detector screen. And the earlier days, you should have some kind of probe, and you have to get you exposed to the high voltage area. And with a non-contact acoustic imager, you will be able to go far away from the high voltage areas, and then you can get the complete picture of the acoustic or the partial discharge. That is the advantage what you are getting. And similarly, you also have the acoustic imagers and the UV cameras, that is the ultraviolet detectors. Usually the ultraviolet detectors actually used for corona detection, or it is called as corona cameras. And there also the light has its own challenges, and you will get very limited information with this kind of cameras, and also has challenges with the daylight. But when it comes to acoustic, it is more easy to use, and it is more rich with the content and the information what you can get. And here is a small video. You can enjoy this. I hope the audio is
Make the invisible visible for faster, easier, and safer electrical inspections. Introducing the Fluke II910 Precision Acoustic Imager, which lets you see the source of partial discharge and arcing, making it easier to quickly scan, locate, assess, and report. The innovative technology uses an array of microphones, listening in high-frequency ultrasound ranges up to 100 kilohertz, to create a sound map which is displayed on the 7-inch screen. The II910 Precision Acoustic Imager enables you to easily scan large areas from a distance, in order to get the job done faster and safer. It's built tough for rugged environments with the precision and reliability you'd expect from Fluke. See the invisible with the Fluke II-910 Precision Acoustic Imager. Find out more at fluke.com.
Yeah, this is actually the acoustic imager, a brief introduction. What we have, it is a kind of camera with 64 acoustic sensors and a visual sensor, which can give you a wide viewpoint, and where you can also, it can capture the entire sound coming from, or the acoustic signal coming from 2 to 100 kilohertz of range. Why 2 to 100 kilohertz? That is the question I was trying to answer earlier itself. Most of the partial discharge sound waveform or acoustic waveform are well within that 100 kilohertz kind of range. That's why this sensor will cover the entire range of partial discharge acoustic waveform. And we also have built-in analytical portion which can analyze what kind of partial discharge is giving. And that is what I'm going to show you. I have shown you, I'm going to show you two case studies which are sample reports what we have generated from one of the customers in Karnataka. That is, here you can see I have, I don't want to name that customer. That's why I have crossed their names. And this is the report what we can generate using the acoustic imager. Here you can see the picture of the image, and also has the artificial intelligence through which it will analyze and then show you what is the kind of partial discharge is present in that. In this picture, it is showing the complete partial discharge is through corona. That means there is no other partial discharge. It is only the corona, and it can be taken easy, because usually the effect of corona is much lesser, and it is usually neglected in our industry. But if it is more and it is going up every time, you may have to, it can also lead into a kind of chemical failures, or it can also affect the nearest components. Okay, that is why this needs to be watched out. This can happen because of the sharp points, or it can happen because of the thin wires, it can happen because of the moisture, or it can happen because of the dust particles. And that's why the cleaning can avoid this kind of partial discharge, the corona discharge. And most of the people today will be aligned or knowing the partial discharge analysis through the partial, that is PRPD technique, phase resolved pattern. And this is what actually our instrument, from the acoustic signal, we have an algorithm built in, and also correlate the sound to the nearest or more suitable PRPD curve. And from this analysis, we are actually arriving at which partial discharge is happening. And again, each partial discharge has its own frequency range and its own sound. And it also gives the indication, like the distance through which the camera and the spot is there, and the partial discharge count, and the frequency at which the partial discharge is making the acoustics. Okay, and this you can also select it, or it can also detect it. That is how it is happening. And in the next example, here you can see the PRPD curve is different. And here also you can see the 73% of is acoustic partial discharge is coming from the corona, and 27% is coming from internal. Okay, this means the bushing or the isolator has some internal damage. It has an internal arcing happening, and this may create a problem very soon. And you can, how this can help, because most of the time what happens whenever we go to a utility company, people say that, okay, because of partial discharge, we never face a problem. But they don't know what exactly happening. Maybe the failures are categorized as a different failure. That may be the reason. And here, if you are not doing this on a periodic basis, this can go up and this can fail the entire system, and this can create more damages. The internal failures can create like this damages in cables and various other things. I have not put many examples here, but many of you will be aware about those kind of situations. And these are all from me, and I hope I am on time. I have taken some 20 minutes to cover this. I'll be happy to answer any questions if I have time now, or I'll be waiting for Mr. Dr. Arora's presentation for that.
Right, sir. We'll come back with the panel discussion followed by Q&A session to take the questions, of course.
Thank you.
So thank you so much, Mr. Prabhakaran, for sharing details on the importance of partial discharge testing, and he has shown case studies also. And delegates definitely you might have received a kind of idea so that how why it is essential to do the partial discharge testing in various methods. So delegates, if you have any question for Mr. Prabhakaran, please submit it in the Q&A box in your Zoom control panel. Don't put it in the chat, please. So now our next speaker is Dr. Rajesh Arora. Dr. Arora has worked in 400 kV and 200 kV substation for more than 14 years in Delhi Transco Limited. He has also worked as Deputy Director at Transmission and Distribution in Delhi Electricity Regulatory Commission, that is DERC, for over 3 years. He has also rendered his services in the SLDC of Delhi Transco Limited. Presently, he is working in the Design and Engineering Department of Delhi Transco Limited as Senior Manager Technical. He will talk on the issues with regards to partial discharge measurement. Welcome, Dr. Arora.
Thank you, sir, Roy Saab. Thank you for inviting me, and I would like to say thank you to you, thank you to Almighty, and thank you to my parents, my mentors. And because of them, I am here right now, and I would like to thank Prabhakaran sir, who has given very good presentation. Now, I am not going to give any presentation because he has already covered whatever related to the partial discharge. And it's very good case study because I am the end user. I am not from any company. I never represent, I never advocate a particular. But I am going to talk the actual issues related to the end user perspective, utility perspective. To go to that points, I would like to summarize whatever Prabhakaran sir has already stated in his presentation. I always love to do the things with fundamentals. There are basically 3 basic concepts in the electrical system, power system. One is your voltage, second your current, and third is the frequency. And entire power system, entire protection system revolves around these 3 parameters: voltage, current, and frequency. When I say current, it has to do with the cross-sectional area, it has to do with the heat, it has to do with the short circuit capacity. It has direct link with the basic instructions. Frequency has their own roles. It creates harmonics, and harmonics creates other catastrophic effects in our system, and we have to control it. Now the topic is about partial discharge in very simple words to make youth understand what partial discharge is. Basically, the leakage in the dielectric system. That doesn't make complete bridge between the live part and the ground, or the 2 live part in 3-phase system, but it is a kind of bridge that is not permanent, that may be intermittent, that is partial in fact, and the name implies it's a partial discharge. And whenever it happens, it brings inhomogeneous electric field. When inhomogeneous electric field is there in any equipment, one thing is bound to happen, that is the breakdown. And we have to avoid that breakdown by proper measurement of partial discharge as the end user. Already explained very well by Mr. Prabhakaran of fluke. Types of PDS, there are 4 types. It is corona, it is arc, it is surface discharge, and last but not the least, it is maybe due to the voids. And the voids usually happens during the manufacturing process. Poor workmanship or some ingress of some impurity during manufacturing process. When we talk about the causes now, the reasons of this partial discharge, it may be due to some moving particles, It may be some fixed particle, it may be due to protrusions, it may be some due to the floating particles, and finally it may be through some voids. Coming to the points, the factors and regions resulting into the PDs. The very first reason for PD in any equipment is the design. We start everything with a design, and after design, it go to production. In production, after production, the equipments go in the transportation. And after transportation, the commissioning start. And after commissioning, severe service condition may cause partial discharge. This is all about the factors resulting into the partial discharge for any equipments. Now coming to why partial discharge testing. It is required, it is good, it is mandatory to check the insulation imperfection, to check the dielectric integrity. It is important to go for that partial discharge testing. When it is mandatory to do that testing, we must have some methods. Now coming to the methods for testing of partial discharge, there are some conventional methods as per IC 60270. There are some unconventional methods governed by IC 666, SIGRE 666, SIGRE 654, SIGRE 622, 6662. And again, conventional methods have limitations of frequency up to 3 megahertz. Then comes unconventional methods, high frequency or very high frequency, 3 to 300 megahertz. Then comes UHV, ultra high frequency methods, 300 to 3 gigahertz. Apart from that, some acoustic methods are also available to detect at the end the partial discharge. That is 10 kilohertz to 300 kilohertz range. Now, what we get after that testing, the question arises, what we get? We get PRD pattern, phase resolved partial discharge patterns. That patterns help us to identify the nature of the fault, nature of the partial discharge in our equipments. Now, how we can get it? Coming to how we can get it. When we say partial discharge, it is always associated with light, optical effect. It is always associated with sound that can be detected with some mechanical system. It is associated with discharge, electrical discharge, dielectric loss, high frequency electromagnetic waves that comes under electrical methods of partial discharge measurement. There are some chemical changes that comes under chemical procedure, chemical method of measurement of partial discharge. It is also associated with the heat, and heat can also be used as a method to detect the partial discharge. Coming to the main components which fails in our systems due to insulation breakdown includes transformer, circuit breaker, disconnector, gas insulated switch gear, cables, joints, cable terminations. Now, time to talk about actual issues for which I have been invited. When I say partial discharge, there are so many players are in the market. But as an end user, as a utility person, there are some issues. Yes, we understand that partial discharge is very important and must be done. But there are some issues with that. It becomes sometimes difficult to go with the online or offline. Both options are there. Sometimes it becomes difficult to retrofit the sensor in the existing GIS systems we have. As an end user, it is difficult to take care of outgoing and incoming cables connected to my system, and how to cover that cables which are connected as the outgoing and the incoming in the partial discharge measurement. How to decide number of sensors, because that are basically decided during design of the GIS system by the manufacturer, OEM only. And important issue as a design engineer is the type tests associated with that part. Either these type tests are not provided, or not conducted, or not shared. But if you look at the specification and of any utility, it is mandated to have your partial discharge kit associated or governed by a particular IC, and that must be type tested according to that IC and the cigarette document or IS code. That is the missing part. Last but not the least, problems as an end user associated with partial discharge kit of any manufacturers. I am repeating, of any manufacturers. Analysis of the pattern, PRD pattern we get. We are totally dependent on the manufacturers of partial discharge measurement kit, or we have to take help of the library being supplied by these manufacturers, and sometimes becomes cumbersome job as an end user to analyze the actual regions of partial discharge in the equipment being used. I have come to the point where it becomes necessary to do the partial discharge testing, and it is for sure can play a vital role in reducing my downtime, my fires, loss of assets and equipments, insulation degradation, overload or stress of my power grid systems. And every session, every talk must be end with a takeaway. And it is my duty to give you the takeaway of this session for which I have been invited. The takeaway is DRAC. Again, I am repeating DRAC. That means every partial discharge must be detected, must be reported, must be analyzed, and after that, the corrective action must be carried out to avoid catastrophic effect in my power system. It should be the safety priority for all engineers, for the equipment, assets, human beings, and livestock. That's all from my side, and thank you very much. Thank you, sir.
Thank you, Dr. Arora, for making an intriguing presentation on the issues with regards to partial discharge measurement and why it is needed. You raised your voice. So, ladies and gentlemen, by now we all know that partial discharge testing is an essential tool for ensuring the safe and reliable operation of high voltage equipment, and we believe it should be included as part of any comprehensive maintenance program. So we will now have a panel discussion on measuring and interpreting partial discharge data, because a huge volume of data is required to analyze. So though Mr. Prabhakaran has touched upon the analysis and diagnosis part briefly in his presentation, we will now try to understand the importance of measuring and interpreting PD data in details. To start with, Dr. Arora, can I ask you why it is important to measure and interpret PD data correctly?
Sir, I have already mentioned That is the takeaway of that session. Every partial discharge must be detected, must be reported, must be analyzed, and finally the corrective action to be taken to avoid catastrophic effect in my power system. Because whenever breakdown happens, it leads to my increased downtime, it may lead to fire, it may lead to loss of life of human beings, loss of the assets, it may lead to the insulation degradation and stress on my power system. Most importantly, whenever there is loss of any equipment, there is indirect burden on general consumer in terms of the tariff we are paying. That's why that partial discharge measurement is very important, must be carried out. This is from my side.
Right. Mr. Prabhakaran, Dr. Arora was talking about the importance of measuring or interpreting PD data. So what are the methods available to get the right data and how to analyze it? What are the solutions available to analyze?
Yeah, thanks for that nice question. In fact, as I mentioned in my presentation, the method of partial discharge detection varies. Okay, there are high frequency methods, ultraviolet method, there are the sound detection methods, and there are the TEV, so-called TEV, that is transient earth voltage method. These are all, most of them are electrical side, and some of those things are online. And as Dr. Arora said, there are difficulties in using different technologies. Each of those technology has its own pros and cons. Most of these electrical systems, electrical sensor-based measurement, you need to fix the electrical sensor well before you charge the equipment. You put the installation. Okay. Once it is installed, it is difficult for you to again put that sensor or adjust that sensor. That's actually difficult. Similarly, the acoustic system can actually give you most of the partial discharge without touching the, or at a safer distance itself. That's why acoustic is becoming more and more preferred one for the maintenance purposes. Okay, for the predictive maintenance or for the actual condition monitoring purposes, acoustic sensors can be used. But same times, whether the acoustic sensor can cover everything related to partial discharge? No. There are certain areas you may have to use the electrical sensors also. You may have to use the high frequency sensors also. That's why you have to choose the right kind of equipments and right kind of analytical methods to identify the condition of these assets. And going back to why this needs to be detected is very, very important, because partial discharge always starts as a small one and it starts growing and finally ends with the flashover, okay, or a catastrophic failure. That means that time period you don't know whether it will, the partial discharge detected today will fail tomorrow or kill your equipment tomorrow or 6 months later or 1 year later. You don't know. That's why you need to monitor it, you need to document it, and you need to have a precise mechanism to ensure that it is the unwanted shutdown is not happening. That is what you have to ensure.
That's very interesting. Mr. Prabhakaran, for the benefits of our delegates for the day, how you were talking about the PD analysis, means data analysis, how PD surveys can provide an asset health check and support maintenance planning. You were talking about the condition monitoring and planning, maintenance planning as well.
This is a very, very interesting and very valid question, because the partial discharge is not a textbook subject. And it need maybe people like Dr. Arora, who has the hands-on experience. And I have come across with one of my channel partner, who is an authority in partial discharge, and he has worked with companies like Qualitrol and all for years. And he actually do that service. And he utilized all kind of equipments. Even he used our acoustic imagers, he used some Qualitrol equipments, he used some other equipments. for the complete, to understand the complete gamut of the partial discharge in a facility and do that analysis. He has something around 25 years or 30 years of experience in partial discharge itself. And that's a good service what he is doing. But yes, the subject is not easy. He should have subject knowledge. He should have the theoretical knowledge. He should have the practical knowledge and its effect. If that is not there, then it is not easy for somebody to interpret it correctly and avoid the mishaps.
So we have Dr. Arora, who is having all those expertise what you mentioned right now. So could you, Dr. Arora, could you mention, could you talk about or could you share your experience on the ground on the part of health check and support maintenance planning for PD?
Yes, we are maintaining all kinds of equipments like transformers, gas insulated substations, major cables, cable terminations, cable joints, circuit breakers, isolator, disconnectors. And as mentioned very well by Prabhakaran sir, it is mandatory to understand the effect of partial discharge. When I say these equipments, there are only 3 types of insulation we can use. We use liquid transformer oil, we use gas, SF6 gas we are using, and we have some solid insulation, polystyrene and others, epoxy we are using in our system. And for all these 3 types of insulations, we have to be careful how to detect a partial discharge. Partial discharge phenomena for the gas and liquid is quite different from your insulator, solid insulator. There are some tracking effect, triggering and tracking effect. In gases, there are ionization of gas, Townsend theory is there. And you have to be very much careful when you are going to do partial discharge testing for a particular equipment, and you should be able to pinpoint particular location where that partial discharge is happening. And as mentioned earlier, it is starting with a very small impact, but finally it is converted into the breakdown.
Right.
We have to avoid that.
So we have to agree that no, partial discharge is not a new topic. This is there since the time electricity has come into force. So
Yes.
of course. And so when you talk about no, and we, at the same time we got to know about the importance of partial discharge testing later on. So now today we have technologies like world-class manufacturers like Fluke. We have world-class solutions provider like Nexen. But how do you see the awareness as of now? So to use the technologies or implement those on ground, Dr. Arora, I will come to you first, then I will take Prabhakaran's input.
Okay, as a design engineer, I have already explained the issues. The issues, very first issue is the availability of the type test. When you are going to procure any new technology, what do you look at? You look at the type test associated, which are governing the equipment you are going to procure. In case that is not available, and in case that is available and the parties, the manufacturers are not ready to share that type test, becomes difficult to take a call. Even if you take a call to purchase, to procure that thing, lack of training, lack of expertise, lack of method to analyze the pattern, you are always dependent on OEM. You are always dependent on the decisions given by that manufacturer, PD manufacturer, what to do next, because you don't have that experience with you. You depend on the library given by that manufacturer, or you depend on the advice given by that manufacturer based on their experience. This is a point where we have to work upon. This is the reasons many people are not going with that partial discharge measurement, even with the advent of new technology available, with the availability of the state-of-the-art equipment available. Still, we hesitate. This is the problem.
Isn't it a serious problem, Mr. Prabhakaran?
The type test.
Yeah, in fact, as Dr. Arora said, the time also is important. Most of the time, what happens when what I felt when I started meeting the the utility customers or the people who are maintaining the utilities into the industries. And we started talking about the partial discharge. My experience with partial discharge is very less. But in the last 2 years, I had met a lot of people. I tried to learn this subject very well. And what I felt is they are aware about partial discharge and its bad effects. But what does matter is when they wanted to do some corrective action, it need money, resource, and time. Okay, that they cannot allocate because there is no provision for that. Okay, there is no method to allocate that. That's why they have to wait till something serious is noted or visible. That is the reality most of the time. Maybe that is a wrong way of understanding. Maybe the financial part and the management and the maintenance team has to come together and analyze what is the kind of failures happened in the previous days or previous years, and then create a kind of mechanism to do the analysis and then a predictive maintenance mechanism. That will help in terms of saving a lot of money and time and even the assets what they are investing, because a transformer or a power plant or a kind of substation is not costing small amount, and the money for that installing it, and when it fails, the complete days it is taking away from the people or the society also is actually a matter of concern. Okay, it can even lead into many other safety issues if such failures comes, right? Some hospitals can go into dark. Some of our facilities, like which is desalination plant, can stop. Those can, this are all a chain effect, because electricity has that kind of power. It is running everyday life of everyone. And that's why you have to have that kind of seriousness and then go with a proper planning. And it will save the time and money, everything what we are incurring.
Yeah, of course, because the kind of damage what we are going to make by not monitoring, it's much more than the kind of effort or cost is needed to monitor, test and measurement it. Dr. Arora, I think we'll be agree with that, of course.
Yes, but I would like to hear something related to the type test I have mentioned many times in my presentation and my talk. What is the view of Prabhakaran sir on that one? Availability of type test.
Right, sir.
Sir, please say something on type test availability.
I think there are some network issues. Yeah. Okay. Dr. Arora, I think there is some, I think it's done. You have answered the question. Okay. Fine. So that was the kind of understanding what we undertook, or rather information I wanted to get from you on the importance of measuring and interpreting PD data. Now I'll be taking some of the questions that are submitted during today's presentations, as well as few questions those are we received on email as well as Facebook. So first question I'll be taking, that was from Miss Vashwati Shen. She is saying that how partial discharge testing relevant in India with its KVA, MVA hierarchy, again a policy level question, with massive number of customer profile to Euro US standard. So Dr. Arora, users experience?
Yes, I already mentioned that it is partial discharge is available even in the LV system. If you avoid that thing, in the beginning, it may have very little effect, but finally it lead to a catastrophic breakdown. You can't afford to avoid it in the present scenario, because availability of assets is very important to run your network, and everything is availability based. Your tariff is also decided based on the availability you are providing to the customers, and you can't afford any kind of breakdown in the present era. It is important. Now coming to the IEC and IS warning, there are some IEC I have already mentioned, 60270 for your conventional method. There are some cigarette documents, 366, 662, 654. You can go through that. These all documents are relevant documents which govern your partial discharge measurement and their requirement.
Would you like to add something, Mr. Prabhakaran?
I think Dr. Arora has put that into right perspective, because he's the right person than me, because I don't work with the standards. And one important thing, yes, when it comes to standards, we are a bit behind. And most of the time, India adopts the IEC or IEEE standards. There is nothing wrong in it, because when something is already, the wheel is already there, why should we reinvent? That's actually good. But implementation and the following those kind of suggestions are very critical. That is what I would like to add.
Right. So
Sir, now Prabhakaran sir is back. I would like to get the answer of my type test related question again.
right. So I'll take the questions of from the delegates. Mr. Sunil Kumar is having quite a few questions. I think 3-4 questions already he put. So he's saying that there are PD partial discharge due to surface impurity or due to internal void. How it can be differentiated using the UV camera? So, Mr. Prabhakaran, sir.
UV camera, it will be difficult because I have no much experience with UV cameras, because usually UV camera tests the light, and that is basically the corona only it will detect. There's internal things and all. I don't think it will do the analysis. Maybe Dr. Arora is raising his finger. That's why let me just clarify that UV, I'm not an expert, but the other techniques, acoustic, definitely, especially what we give is having an internal algorithm, and where we actually give how much portion of this different category of partial discharges coming. Maybe those kind of artificial intelligence is there or algorithm is there in the UV. Yes, that may help. Yes, sir.
Yeah, infrared camera and when we talk about partial discharge, is a major difference. In simple words, I can explain. Infrared camera basically detects the heat, and that heat is because of the loose connection and the flow of heavy current. Whereas the partial discharge has linked directly to the dielectric weakness, dielectric impurity, dielectric integrity. One works for your current and a loose connection, and second works for your impurity in the insulation. It's a major difference.
Okay. I think that answered the question of Mr. Sunil Kumar. Mr. Arvind is asking, how can we know whether it's internal or external partial discharge on acoustic imager? Mr. Prabhakaran?
I'll take that call. I think right. I'm the person for yeah. I hope I'm audible. In fact, acoustic imager, just an acoustic imager will not give you the clarity, which one is there. What is actually required? There are hundreds of papers in the open domain available, and there are research happened. What are those frequencies? What are those pulse count? What are those dB levels associated to different kind of partial discharge? Okay, based on those studies, what Fluke has done an algorithm built into the software. And once you get this signal, the acoustic signal, it analyzes it and then give you what kind of partial discharge it is. That is what we does. That's why every acoustic imager is not same. You have to choose the acoustic imager which has that capability to do the analysis and then give you the real clear-cut information what you really need. Otherwise, you will have an acoustic imager, but you may not have the right information what you need. That's why you have to be very careful. Okay, that you would have seen the report what I have shown in my presentation, where in that report the percentage of partial discharge is mentioned. That is how you can identify that. Yes, sir.
Yeah,
I would like to share my experience. When you are using the acoustic as a partial discharge measurement, in acoustic, you are using that acoustic during the online condition. Initially, what you do, you identify the fault in a coarse manner. Then you try to fine tune it by reducing the spacing between the external sensors on the equipment. This way you can get one pattern, and based on the pattern you receive, you can differentiate whether it is because of some voids or some external particle protrusions or anything else.
Yeah.
Okay, that's great. So Mr. Abhishek Gupta is having a very interesting question, that how can you quantify the loss, or how can you measure the loss in terms of money for the PD discharge? Yes, Dr. Arora.
That can be done in a very easy manner, because if you are belonging to a particular state in India, in every state, one tariff order is issued. In that tariff order, the rate of energy is given. Suppose you, because of partial discharge, your lines is out for this much or time, for this much hour, you can quantify the energy loss, and that energy loss should be multiplied by the rate of that energy for that particular voltage level. That will give you in terms of money loss.
Are the states actually publishing this sort of data?
Yes, they are. It is mandatory to have that tariff order for every state in India.
Yes, Mr. Prabhakaran, you want to say something?
And over to that, what equipment you are going to replace? That is
Right.
a cost.
Exactly.
And when partial discharge is failing something, the time you are wasting on restoring that also is a cost of money.
Right.
And the equipment, if it is a transformer or a cable or a capacitor, which is you need to replace, you can't repair it.
Right.
Once partial discharge failure, flashover is there, nothing is left out.
That
Okay.
is covered under the availability of that utility, availability pattern.
So that's the downtime what you are.
Yes, downtime. Exactly.
Right. So, then Mr. Kalyani is asking that we have online PD as well as offline PD. Which one is better?
That was my.
And why? Yes, Dr. Arora.
Okay. And offline and online, that depends utility to utility and their requirement. For when I start talking about my utility, we don't have online right now. We are using the portable offline, and these are used as and when required, or it are used based on specific time period given in the maintenance schedule or condition monitoring schedule of that equipment. Yes, always online monitoring is always better. It gives you continuous pattern of all the equipment. There is no doubt about it. If your utility can afford that thing, nothing better than that.
Okay. Yeah.
I would like to add here, it again, as Dr. Arora said, it depends on your purpose and if your affordability and where you want to use it, especially when it comes to the yards and the transmission lines. It will be difficult for you to use an online system with a very cost-effective way. You may have to install it upfront, and after a long period of time, some of the sensor would have gone bad itself, because your electrical utility equipments has a larger life than the sensors. Okay, that is another big tragedy in the entire scenario. And that's why what I would suggest is you have to choose this wisely. If you have money, maybe the largest assets, you can have the continuous monitoring online. And for the other things, for the periodic maintenance, you can have an effective offline cameras or acoustic systems or other systems that will give you the freedom to go and then do the inspection every now and then when you want it, periodically. Invasive system. Okay, you need to have a shutdown. Okay, that is not all, most. Okay, that is not actually practical for you. Thus, you have to choose it and balance it out.
So, Mr. Prabhakaran, I just wanted to understand from you that do you even suggest utilities that the kind of solutions, whether it's online or offline PD testing or diagnostic tools, they should monitor for the particular location depending upon the budget what they have?
Yeah, see, actually, as a salesperson or as a person who is selling one particular acoustic imager, my personal motive will be to sell my product.
Right.
Okay. But in this forum, I don't want to just talk that only that. What we do is we understand what is the pain areas of our customers.
Exactly.
And we recommend different options.
Right.
Okay. And we show them what exactly benefit they can get from my solution.
This is what I actually.
Yeah. So that what happens, the customer has the information for taking the right useful solution. That is what Fluke believes in. It is not just pushing my product and then leaving. We also have the responsibility to understand and educate the customer to choose the right kind of product. That's what we do.
Right. So they can take the learned decisions, of course.
And more importantly, in India, most of the utilities are headed or having a technical expert, okay, who has good knowledge than any of the people who are selling the products. Okay, that's why we always respect them, and we always try to put our case and show them what advantage we can, because it is not easy for fooling. That is, it is actually telling what options, what technology is available, and choose this, and this will help you in addressing so and so things. I'm still telling, I will not be acoustic imaging may not address 100% of your PD requirements. I may address 70%. The rest of 30 you have to have other technology.
Okay. So during your presentations, you mentioned about Corona PD, then surface PD, and internal PD. Our delegates are actually listening to this your presentations very carefully. And again, Mr. Tadishwani Kalyan, he's asking that how do you know that which PD, and based on the test and analysis what you do with this thing, and what kind of PD it is, whether it's Corona, surface, or internal?
Yeah, I think I have answered that earlier through that the report. There is a report generation which actually indicates which is that Corona you are or which is that partial discharge available there. The technique is same. We are taking that frequency, taking that the discharge rates. We are taking the dB levels, and then analyzing and then telling you what is the percentage of these components available in 100% of that partial discharge. That's what we do.
Okay. So Mr. Sunil Kumar is asked, okay.
And one thing what you can do is how you can correlate whether this is good today and bad tomorrow, like that. How do you analyze that?
Right.
You have a periodic mechanism and recording.
Okay. So that's a continuous process you need.
It is a continuous process. It is not one-time measurement.
Exactly.
Definitely not.
So Mr. Sunil Kumar is asking that PD is a very effective testing method to detect the healthiness of an insulation. So can you show some photograph of the camera differentiating the internal void and surface tracking? Thank you. I think
I have shown. What I can do is we have hundreds of such documents and the reports we have created from some customers. I will not mention the customer names, but I can share those information if you can share me the email ID or I can.
So Mr. Sunil Kumar, can you just you reply to the feedback? You will be after this session, you will be receiving a feedback email. Please reply to that mail. We will share the details with you. Then again, his question was whether the internal insulation weakness can be detected using the PD camera. It's possible.
It is possible.
Okay. How to handle noise and offer correct interpretation? Dr. Arora, can you take that?
To take care of all these noises, we are using the unconventional method I have already mentioned, as covered by Segre 366654662. These usually take care of the noises, and they differentiate the actual noise and the actual PD very well. They have their inbuilt quality, and more light can be thrown by Prabhakaran about the product available in the market.
I would like to add there are in our camera there are methods, because the frequency of partial discharge is unique, or maybe it has certain things, and the noise what you are going to get it in a different frequency range. Okay, that's why you can select and avoid other frequencies. That's another method in our instrument. We adopt that. Okay, every noise, every acoustic frequency is different, right? That's why you can just select those bandwidth and then get you the right kind of thing. You can point or zero down on the actual frequency of interest.
Right. So Abhishek is having one more question: how to get PD rectified? I think PD, you can do the diagnostics, and how you can rectify it, it's up to the utilities. Dr. Arora?
How to rectify the issues? I have already mentioned this is the take up of my session, DRAC. detect it, report it, analyze it, and do the corrective action to avoid further catastrophic effect, further breakdown of your system, downtime of your system, save money, life, everything.
Yeah. I think one way of rectifying it, it all depends on which component is actually having the failures. If it is a cable, most of the time the cable joints can have a issue. And if you, the practice is basically any HV or MV cables, you have to, while installing itself, you have to have a partial discharge detection. Okay, if you find that, then it is easy. You can just take that joint and then replace it, or take that cable itself and then do the replacement. But if it is a kind of existing one transformer installed for ages, and then if you are finding there is a partial discharge inside, the only option what you have is you take it out of the service, right? But usually what happens, you need to take the time analysis, whether it is really the time for doing it, or if you have the standby to change over. All those things are also practical difficulties. You have to make that mechanism, how to take that out of service and then do the rectification. Possible to avoid partial discharge catastrophic failures.
Right.
But you should have that information, whether it is having discharge or not. Yes, sir.
Okay, Dr. Arora, yes.
Sir, I would like to add one more thing here. Yeah. In every utility, there is one expert group committee is available, and you have to report all these problems, partial discharge to that committee, and based on the analysis and the corrective action suggested by that committee, the action to be taken. That action may be replacement of equipments. That action may be continue for some time with that equipments to avoid the downtime, to maintain the availability. That depends, and severity of that partial discharge analyzed by that committee.
Okay. So this is a follow-up question of Abhishek again. So what he's, I think, trying to ask that with those PDs, PD testing, is it possible to analyze the degree of damage is being done, or the, I think that is what, or what kind of repair it is, whether it needs urgent repair, or that should be replaced then and there, or what is the risk available with that? Is it possible to get such data?
Sir, I have already mentioned in the previous reply that goes to expert committee, and it is the purview of that committee to decide upon the corrective action to be taken.
It's a manual system. There is no data.
No. It's a manual. It's a total manual system.
Okay. And any threshold? Yeah.
It again depends on, because that's what I mentioned earlier. The partial discharge failure can take 1 hour, a few seconds,
right,
or a year, or even many years.
Right.
It depends on various things: the material strength, the environment, the electrical stress, or the environmental stress, or mechanical stress. Many things are there. That's why you can't one medicine is not there for every partial discharge. That's why this is a tricky question, and there is no simple answer for that.
And any threshold limit of PD is asking? Like any threshold limit of partial discharge?
Sir, that depends on the partial discharge we are getting. And for every partial discharge, there's some pattern. Based on that pattern, we can identify the quantum of imperfection of insulation and action to be taken accordingly.
Okay.
Because the PRPD analysis itself, majority of the engineers may not be aware how to analyze, how to read the PRPD. Okay, that's why how you can read the PRPD and interpret that. That also make a difference. And these expert committee members may be able to do that very easily for you. That is what we have to recommend.
Okay. So Divyang is asking, Divyang Raval, yeah. Which are the various types of sensors used to detect partial discharge? If you have.
We have some inbuilt sensor given by the manufacturers of GIS. Sometimes we use external sensor. Sometimes we use CT, high voltage CT around the cable termination and cable to get the PD pattern.
Yeah.
And an attendee is asking which is the best method for PD. Again, that can be hypothetical. It's depending upon the situation.
Right.
Okay. Mr. Sarath is asking, is there any limitations for inception and what is that voltage during measurements? Okay.
We
Is there
already answered all.
okay. Is there any hybrid system available between online and portable? Mr. Prabhakaran, yeah.
I really don't know, in fact, because I have not seen a kind of integratable thing that is a online with a offline, and then it can integrate with the software and all. I have not seen it. Maybe that is the future. It will have both the side, that is one is online and the other one is offline, and you will be able to correlate or integrate these results and do the analysis for a more detailed analysis. That's what is going to happen.
Okay. Dr. Arora, I think you have already done something.
Yes, yes. In many utility, what happens when you notice that for a particular sections of my JS, it is giving the frequent troubles of PD. We fix that to sensors for permanent, that becomes my online systems. And for other part, we just stick to my offline system. That is kind of hybrid. For the same utility, some part is online and some part is offline. Depends on the nature of fault, the location, and the conditions of load.
Okay. Abhishek is asking, can I use PD for customized electric machine?
You can do it.
Not substation for 4 and 5 volt control panel. It's possible. Yeah. What kind of machine can be used for 4 and 5 volt control panel, Mr. Prabhakaran?
Pardon me? I missed it.
Abhishek is asking that, can I use PD testing for customized electric machine, not substation? That is for 4, 1, 5 volt control panel. He wants to use it there. Is it possible?
It can be because see, that is where in one of my slide I have mentioned two applications. One is for the utility for the transmission distribution kind of application. The other one, even in the video I have shown you, the stator testing. Okay, basically, when you are manufacturing any of those MV or HV equipments and then components, you need to have that kind of testing. And people are using it. And most of the time they use the high voltage applying the partial discharge voltage levels and then testing it. But what the acoustic imager can help you is it can detect and pinpoint where exactly it is happening. When it is a kind of manufacturing facility, it is much easier, and he will be able to identify the exact point of problem and rectify it then and there.
Okay, so Fluke has got solutions for that as well. Acoustic image. Okay. Sriram is sharing his opinion that we learned and very informative session. Thank you, Mr. Prabhakar and Dr. Arora. And his question is that why this corona partial discharge happened? What is the reason? Dr. Arora, who knows that better?
Corona partial discharge is basically the ionization of air around the conductor carrying that current. And because of that flow of current, some magnetic field is there, and that magnetic field ionize the air around that conductor. That is the corona discharge basically. That is not very harmful in the beginning, but you have to take care of that thing also during partial discharge measurement.
Okay. So Sunil Kumar is asking, presently the preventive maintenance measures includes IR test and tan delta measurement, whether the PD test will give a clear indicative value for showing the insulation healthiness of a system, and what is the approximate budgetary cost for the Fluke PD measurement equipment, if you can just.
See, there are, that's what, even tan delta is one method of doing the testing. And I don't think it will give you the entire thing of partial discharge. It has some limitations of its own, and it's a bit bulky equipments again. Taking it to various locations is not easy. Like that, every instrument has its own pros and pluses and minuses. And acoustic imager, definitely, it is a much easy to use portable equipment. And you can see the partial discharge from a distance itself. That is, safety is paramount for you, because you can't go near to the very close to the equipments. That's why you have to go a little bit further and then do the acoustic imaging or the analysis from a farther distance. That makes it easy and accurate. Okay, that is one. And when it comes to the cost, yes, we have the cost range. We can give you the, because I don't look up the sales portion of it, and it varies. I think we have different models, varies from 15 lakhs to 25 lakhs kind of price we have. Okay. And it depends on the models.
So for one last question, is there any limitations for inception voltage and extinction voltage during PD? That's Sarat's question.
I don't know.
Dr. Arora, will you take that?
Yes, yes. I think there is no as such voltage level there. That all depends on the PRD patterns we are getting, and based on that, we identify the type of fault, type of PD in that equipment, and based on that, the corrective actions are taken.
So it's almost at the end of the session. Would you like to summarize something and why we need no PD testing and what sort of initiatives to be taken by utilities, Dr. Arora?
Yes, yes. I would like to end with my takeaway of session. DRAC. All the partial discharge, whenever you come across that thing, must be detected, must be reported, must be analyzed, and corrective action to be taken to avoid further breakdown or catastrophic effect. That is and all about from my end. And thank you very much.
Your concluding statement, your takeaway for the session, Mr. Prabhakaran.
Yeah. In fact, as we discussed in length, partial discharge is a real kind of cancer in a utility system. And if you detect it early and take appropriate actions, you will not get into that stage 4 kind of situation, and then you can still have time to save your life or your equipment's life. That's why money and efforts and time can be saved, and the safety of the plant, men, and your surrounding can be ensured by an appropriate partial discharge detection and taking the appropriate action to contain it. That's what.
Very rightly said. Very strong statement coming from Mr. Prabhakaran. Your partial discharge is like cancer, and it can be cured. No, it's curable if if we take necessary action on time. And it was great, Dr. Arora's inputs as well. So thank you again, Dr. Arora and Mr. Prabhakaran, for answering those questions as well as sharing your presentations today. It was my pleasure having you here. Thank you, delegates, for attending and make the session very, very interesting with your questions. We hope you have enjoyed this session, and we hope you enjoyed this Mojo for Industry Development debate on why partial discharge testing is important. The knowledge partner for the session is Fluke Corporation, and co-sponsor was Next Gen Equipments Private Limited. One more announcement, as usual, we will soon premiere an edited video of the entire session on our YouTube channel, Mojo for Industry Media. Please subscribe to the channel and you will get the notification. So this concludes the session. Thank you for participating in today's development debate. We hope to see you again next time. Till then, take care and stay safe. Thank you, Dr. Thank you, Mr. Prabhakaran. Thank you, sir. It was great talking to you, both of you, actually. It was very, very interesting session.
Thank you, sir. Same here.
Thank you.
Our pleasure, sir. Thank you, sir.